All right, let's go.
Number 7, the cosmological argument. Everything that begins has a cause. The cosmological argument is the oldest serious case for a creator. Aristotle proposed a version of it in the 4th century BC, the idea of a prime mover, something that started the chain of cause and effect without itself needing a cause. Thomas Aquinas expanded it in the 13th century. The modern version, most discussed today, is called the Kalam cosmological argument, developed by Islamic theologians including Al-Ghazali in the 11th century and revived in contemporary philosophy by William Lane Craig. The structure is simple. Whatever begins to exist has a cause. The universe began to exist. Therefore, the universe has a cause. The argument rests on the observation that nothing in our experience pops into existence without something causing it. Proponents argue that an infinite regress of causes, an endless chain stretching backward forever with no starting point, is logically incoherent, because you cannot traverse an actual infinite series of past events to arrive at the present. There has to be a first cause. And proponents like Craig argue that this first cause must be timeless, spaceless, immensely powerful, and, critically, personal, because only a free personal agent can choose to bring about a temporal effect from an eternal, changeless state. An impersonal mechanical cause, they argue, would either have always been producing its effect or never would. The observational support comes from modern cosmology. The universe, as best we understand it, did have a beginning, the Big Bang, roughly 13.8 billion years ago. If time itself began at that point, the argument states the cause of the universe must be something outside of time altogether. The strongest objection is not new. Why does the first premise, everything that begins has a cause, apply to everything except the proposed first cause itself? If something can be uncaused, why not the universe directly, without the extra step? Philosophers have debated this exact point since Aquinas' century. Number 6, the fine-tuning argument. The universe is tuned like an instrument. This is the most scientifically detailed argument for a creator because it works directly with the constants of physics rather than abstract logic. The strength of the strong nuclear force, the strength of gravity, the mass of the electron, the cosmological constant, every one of these values appears to sit within an extraordinarily narrow range that allows stars, chemistry, and life to exist at all. The cosmological constant, the value that determines how fast the universe expands, must be balanced to roughly 1 part in 10 to the 120th power. If it were even slightly more positive, the universe would have flown apart before galaxies could form. If slightly negative, it would have collapsed back on itself almost immediately. If the strong nuclear force were a few percent weaker, atomic nuclei more complex than hydrogen could not hold together. No carbon, no oxygen, no chemistry of any kind. If gravity were significantly stronger, stars would burn through their fuel in thousands of years instead of billions, leaving no time for life to evolve anywhere. Proponents of the fine-tuning argument, including physicists and philosophers across multiple academic traditions, argue that the precision of these values is too extreme to attribute to chance. They argue it points toward intentional design. The leading scientific counter-argument is the multiverse. If there are an enormous or infinite number of universes, each with randomly different physical constants, then most of those universes would be lifeless. But we obviously could not observe a universe that did not support life, so observing a finely tuned universe is not surprising. It is what any observer must necessarily see in any universe capable of producing observers at all. This reasoning is called the anthropic principle. Some theoretical frameworks, including string theory's landscape of possible vacuum states and inflationary cosmology's prediction of multiple bubble universes, suggest a genuine mechanism by which such a multiverse could exist. None of these frameworks has been confirmed experimentally as of 2026. Number 5, the no-boundary proposal, a universe that never needed to begin. In 1983, physicists James Hartle and Stephen Hawking proposed a model that directly challenges the premise that the universe needed a cause at all. In standard physics, time begins at the Big Bang singularity. Before it, the question, what caused this, assumes there was a before in which a cause could exist. Hartle and Hawking proposed using imaginary time, a mathematical reformulation of time near the beginning of the universe, under which the universe has no sharp starting boundary at all. In their model, asking what happened before the Big Bang is like asking what is south of the South Pole. The question does not fail to have an answer, it fails to make sense, because the geometry rounds off smoothly with no edge anyone could fall off of. If the no-boundary proposal accurately describes the early universe, the cosmological argument's first premise, the universe began to exist in the sense of having a discrete starting point requiring a cause, may not apply in the way it is typically assumed to. The universe would simply be a finite four-dimensional geometry with no boundary, the same way the surface of a sphere is finite but has no edge anyone could fall off of. Hawking explicitly framed this model later in his life as removing the need for a creator. He argued that if the universe is self-contained in this way, having no boundary and no edge, then it would simply be, with no need for anyone to set the initial conditions. Critics, including some theologians and philosophers of physics, respond that the no-boundary proposal still requires the laws of quantum gravity and the mathematical structure underlying it to exist in the first place, and that explaining the absence of a temporal beginning does not by itself explain why there is a coherent set of physical laws capable of producing a universe at all. Number 4. The eternal or cyclical universe theory. No beginning to explain. If the universe never had a beginning, the cosmological argument loses its second premise entirely. There is nothing that began to exist. Several physical models attempt to describe a universe with no true starting point. Eternal inflation proposes that the inflationary field that drove the rapid early expansion of our universe never fully stops. It continues forever in some regions, perpetually spawning new bubble universes, each with their own Big Bang, in a process with no beginning and no end. Cyclical models, including the ekpyrotic scenario developed by physicist Paul Steinhardt and Neil Turrow, and earlier oscillating universe models from the mid-20th century, propose that our universe is one cycle in an endless sequence of expansions and contractions, each Big Bang actually a big bounce following the contraction of a previous cosmic cycle. If any of these models are correct, the universe, in the broadest sense, the totality of all that exists, including whatever came before our local Big Bang, never began. It has always existed in some form. There is no first event requiring a first cause because there was no first event. The challenge facing all of these models is the same. None of them has produced a confirmed observational signature. The 2025 BICEP array and other gravitational wave detectors continue searching for primordial gravitational wave signatures that could distinguish between inflationary, cyclical, and bounce cosmologies. But as of 2026, no model has been confirmed over the others. The question of whether the universe, in the deepest sense, had an absolute beginning remains scientifically open. Number 3. The quantum fluctuation theory. Something from nothing without a mind behind it. Physicist Lawrence Krauss popularized this idea in his 2012 book, A Universe from Nothing, building on decades of work in quantum field theory. The proposal is that the universe could have originated from a quantum vacuum fluctuation, a spontaneous event permitted by the laws of quantum mechanics, in which nothing is not philosophically nothing, but a quantum vacuum state, which is itself unstable and capable of giving rise to particles, energy, and potentially entire universes without any external cause or agent. Quantum mechanics has demonstrated in laboratory conditions that virtual particles can spontaneously appear and disappear in a vacuum governed entirely by the uncertainty principle, with no external trigger. Extending this principle to the origin of the universe itself remains speculative, but proponents argue that something from nothing is not philosophically absurd. The laws of physics themselves permit spontaneous emergence under specific conditions. The most common philosophical objection is that the vacuum in quantum field theory is not actually nothing. It is a quantum field obeying physical laws, with structure, energy, and properties. Critics argue that a true philosophical nothing, the complete absence of laws, fields, space, and time, cannot spontaneously produce anything, because there is nothing there to obey any law in the first place. Proponents respond that demanding an explanation for the laws of physics themselves is a different question entirely from explaining the origin of matter and energy within an existing framework of law. Number 2. The first cause need not be a mind, a cause without a creator. This theory accepts the logical structure of the cosmological argument that the universe likely has some kind of cause or ground of being, but rejects the leap to a personal, intentional creator. Philosophers in this camp argue that the cosmological argument, even if fully sound, only establishes that something timeless and uncaused exists at the foundation of reality. It does not establish that this foundation has intentions, awareness, or personhood. An abstract mathematical structure, a physical law, or a brute fact of necessity could in principle serve as an uncaused first cause, without being a mind of any kind. Philosopher Bertrand Russell, in a famous 1948 debate with Frederick Copleston, argued that the universe could simply be accepted as a brute, unexplained fact, that demanding an explanation for everything, including existence itself, may be a demand the universe is simply not obligated to satisfy. He called the universe just there, and that's all. This position occupies a middle ground in the debate. It takes seriously the philosophical weight of why does anything exist at all, without assuming the answer must be a deliberate, personal, conscious creator. Critics from the theistic side argue this leaves the deepest version of the question, why this particular set of laws, this particular structure, rather than nothing or something else entirely, completely unaddressed. Number 1. The simulation and designer theory. A creator without a deity. A growing number of physicists and philosophers take seriously the possibility that whatever created the universe may not be supernatural at all, but rather an advanced intelligence operating from within a different physical framework, a parent universe, or a computational substrate. Nick Bostrom's 2003 simulation argument proposes that if civilizations capable of creating high-fidelity simulated realities are common, statistically most conscious experiences would occur inside simulations rather than in a single base physical reality. Under this framework, a creator of the universe could be an advanced intelligence running a simulation, fundamentally a creator, in the most literal sense of having authored the conditions and laws governing this reality, but not a deity in the traditional theological sense. Separately, some physicists have speculated, outside the mainstream but seriously, in published theoretical work, that black holes might give rise to new universes on their far side, meaning our own universe could be the interior of a black hole formed inside another larger universe. Under this model, the creator of our universe would simply be whatever massive collapsing star or structure produced the black hole that birthed it, a physical process, not an intentional act. These theories reframe the entire question. They suggest that did the universe have a creator and did the universe have a deity may be two separate questions with two separate answers, and that the cosmological and fine-tuning arguments, even if they succeed, may only get you part way to a designer without ever establishing what kind of designer it is. 7 theories. The classical argument that anything that begins must have a cause, and that cause must be personal. The fine-tuning of physical constants so precise that 1 part in 10 to the 120th power separates a livable universe from total chaos. A model where the universe has no boundary at all, and therefore no beginning that needs a cause. A universe that simply never began, cycling or inflating forever. A vacuum fluctuation governed by quantum law rather than intention. A first cause that is real but not a mind, and a creator that might be a civilization or a physical process rather than anything supernatural. None of these are settled. Physicists disagree, philosophers disagree, theologians disagree. The question of whether the universe had a creator sits exactly where it has sat for over 2,000 years, at the boundary of what physics can measure and what only philosophy can attempt to answer. Subscribe to Cosmic Hives. See you in the next one.